One of the things that positions SolidWorks software so far above the competition is the broad array of mates that are available. Mates create geometric relationships between assembly components. As you add mates, you define the allowable directions of linear or rotational motion of the components. You can move a component within its degrees of freedom, visualizing the assembly's behavior. The easiest way to add mates is with the Quick Mates toolbar. These mates cover the majority of the mates that are added to an assembly and require minimal interaction. Just select the items to be mated and SolidWorks presents a toolbar showing only the mates that are relevant for the selected items. The Quick Mates toolbar includes standard mates such as coincident, parallel, perpendicular, tangent, concentric, lock, distance, and angle mates. You can see how easy it is to add these mates. In fact, 7 mates have been added to this assembly in just 30 seconds. The standard mates are straightforward and can be applied rapidly with the Quick Mates toolbar, or by using the Property Manager, which provides access to advanced mates and mechanical mates. A symmetric mate forces two similar entities to be symmetric about a plane or planar face of a component, or a plane of the assembly. The width mate is a very powerful mate that saves a great deal of time by allowing you to center one component to another without having to compute the offset distances. The path mate constrains a selected point on a component to a path. You first define the path by selecting one or more entities in the assembly. Then you can control the distance along the path and define the pitch, yaw, and roll of the component as it travels along the path. A linear coupler mate establishes a relationship between the translation of two components. When you create a linear coupler mate, you can set up the motion of each component with respect to either ground or a reference component. The distance and angle mates are standard mates that allow you to define the linear or angular offset between two entities. These mates are taken to the next level in the Advanced Mates section by providing control of the offset between a range of values. To control the stroke of this cylinder, you first establish a starting distance and then define the minimum and maximum distance allowed. Similarly, you can apply an angle mate to control the rotation of the motor. You can use the same technique to enter minimum and maximum angle values to control the rotation. A cam follower mate is a type of tangent or coincident mate. It allows you to mate a cylinder, plane, or point to a series of tangent extruded faces, such as you would find on a cam. You can create the profile of the cam from lines, arcs, and splines, as long as they are tangent and form a closed loop. Slot mates are a tremendous time saver. Simply select a cylindrical face or axis and a face from the slot, and SolidWorks positions the pin in the slot. The pin can move freely along the length of the slot, be constrained to the center, or positioned at a distance or percentage along the slot. And the slot mate works just as well on radial slots too. Hinge mates limit the movement between two components to one rotational degree of freedom. It has the same effect as adding a concentric mate plus a coincident mate. You can also limit the angular movement between two components. Again, this mate saves time because you only have to add a single hinge mate instead of a coincident, concentric, or angle limit mate. When working with gears, the gear mate and the rack and pinion mate are very handy and simulate realistic motion. When you choose the rack and pinion mate, SolidWorks evaluates the pitch diameter. The linear translation of one component, the rack, causes circular motion in another component, the pinion, and vice versa. Similarly, for the gear mate, SolidWorks extracts the pitch diameters and allows them to rotate relative to one another about their axes. The screw mate constrains two components to be concentric, and also adds a pitch relationship between the rotation of one component and the translation of the other. Translation of one component along the axis causes rotation of the other component according to the pitch relationship. Likewise, rotation of one component causes translation of the other component. Finally, the universal joint mate is very useful when designing a cardan shaft. A universal joint connecting two shafts at an angle causes cyclical motion in the output shaft. This mate solves the equation of motion without having to assemble and mate the spiders. This is often overcome with a double cardan shaft, where the input and final output shafts are parallel. You can clearly see this in the motion simulation, charting the angular velocity of the three sections. Rapid assembly techniques with the QuickMates toolbar and the most comprehensive set of assembly mates in the industry will help you assemble your designs with ease and simulate their real-world function.